Hi everyone! Are you not wondering why you're able to communicate with your loved ones from far places? How are you able to listen to your music from your radio? Or how your television remote control works? Well, today we will be discussing the second quarter's module 2, which is the practical applications and effects of electromagnetic waves. But since this topic is too broad, we will be doing subtasking. So for now, we will just focus on the practical applications of electromagnetic waves. And, as expected, you should have to cite examples of practical applications of the different regions of electromagnetic waves, such as the use of radio waves in telecommunications. But before we start, let me test first your prior knowledge regarding this lesson. Read each question carefully and choose the letter of the correct answer. You may do this in your science notebooks. Now, check your work using these key answers. Can you still remember the different forms of electromagnetic waves you have learned from your previous modules? While all the EM waves move through space at the same speed of about 300 million meters per second, their wavelengths, frequencies, and energies differ. This is the reason why they are arranged accordingly in a scheme called electromagnetic spectrum. Let me remind you that the wavelength has an inverse relation with the frequency and the energy. So, if wavelength increases, what will happen to the frequency of the wave? And if the wavelength of an electromagnetic wave decreases, what will be the effect in its energy? And now, let's compare the relative wavelength, frequencies, and energies of the different regions of electromagnetic spectrum. On a separate sheet, answer the following activity. Look at the picture below. Write the name of the correct electromagnetic wave corresponding to the letters on the picture. You may refer your answer from numbers 1 to 7 from the box. Do this in 30 seconds. Now check your answers with this. What letter shows the lowest frequency? What letter shows the shortest wavelength? What letter shows the EM wave with the highest energy? Were you able to answer it correctly? Look for the name of devices hidden in the puzzle. The words may be placed vertically, horizontally, diagonally, or even backwards. Write in your notebook the 10 terms you found in the word box. Do this in 60 seconds. Now, check your work using these key answers. What do you think are these devices for? And what form of electromagnetic waves make them work? So these are the electromagnetic waves and its practical applications, which depends on its wavelength, frequencies, and energies. The first electromagnetic waves that we will be discussing are radio waves, and its practical applications are radio or television signals. Radio and television signals are radio waves that are produced by making electrons vibrate. It has a long wavelength capable to transmit sound and picture information over long distances. Global Positioning System or GPS is a space-based navigation system that provides geographical position and time information anywhere on or near the Earth. It communicates with stations on the ground using radio waves. Magnetic resonance imaging or MRI. It is a medical imaging technique that uses powerful magnets, computer, and radio waves to make detailed pictures inside your body. Another electromagnetic waves that we will discuss are the microwaves. Its practical applications are satellite communication. Microwaves are used in satellite communications because it can penetrate the Earth's atmosphere. Microwaves signals are transmitted by an antenna to a satellite which amplifies and retransmits the signal to an antenna in other parts of the world. This is how we communicate even from afar. Another one is terrestrial communication. A cell phone is a radio transmitter and receiver that uses microwaves. Cellular phones depend on overlapping network of cells. Each cell has its own tower that receives and sends microwave signals. Another one is cooking. The microwaves in a microwave oven penetrate and agitate the water molecules within the food. Thus, they create molecular friction which produces heat that will cook the food. Radar, or radio detection and ranging, is a detection system used to determine the range, angle, or velocity of objects. It can be used to detect aircraft, ships, and the like. Another electromagnetic waves that we will be discussing is the infrared. Its practical applications are remote control or IR remote. It uses LED lights to transmit signals to control devices. It emits pulses of invisible infrared light. Another one is thermal imaging through infrared scanners. Infrared scanners such as thermal imaging and thermal scanner are used to show the temperature variation of the body. Our body radiates infrared, and under infrared cameras, our images appear in a variety of colors. The differences in color determine the differences in temperature. For example, shades of blue and green indicate regions of colder temperature, and red and yellow indicate warmer temperature. Another one is night vision goggles. Use thermal imaging technology to capture the infrared light being emitted as heat by objects in the field of view. Another electromagnetic waves that we will discuss is the visible light. Its practical applications are enables us to see things around us. It also gives light to the screen of most electronic devices. Artificial lights like flashlight, lamp, etc. are any light source that produce light instead of natural lights produced by the sun. Optical fibers. One use of optical fibers in medicine is endoscope, a flexible tube with tiny camera that is used to observe the internal parts of the body. Another electromagnetic waves that we will be discussing is the ultraviolet or UV. Its practical applications are Ultraviolet B or UVB radiation in sunlight interact with a protein or 7-DHC in the skin, converting it into vitamin D3, the active form of vitamin D, which is essential for maintaining healthy bones and teeth. Security markings. Sensitive documents such as credit cards, banknotes, and passports include a UV watermark that is only seen under UV emitting light. Sterilization of water in drinking fountains. Ultraviolet light disinfection is one water treatment system that can be used to remove most forms of microbiological contamination from water. Fluorescence. Some washing powder contains fluorescent chemicals which glow in sunlight. This makes your shirt look whiter than white in daylight. Another type of electromagnetic waves that we will be discussing are X-rays. Its practical applications are diagnosing bone fractures. X-rays are produced using an X-ray tube. They are emitted when fast-moving electrons hit a metal target. Long-wavelength X-rays can penetrate the flesh but not the bones. That's why it is used in diagnosing bone fractures. Airport security scanner. The short-wavelength X-rays can penetrate through metals, which can be used in airport security scanner. Another electromagnetic waves that we will be discussing are the gamma rays. This may be the last but not the least because it has the most energies among all electromagnetic waves that we have discussed. Its practical applications are treat tumors and cancer through the process called radiotherapy. The high energy rays of gamma destroys cancer cells in the area where it is given. Gamma rays sterilize surgical instruments too because they easily penetrate through materials and the energy they release kills bacteria and other microorganisms. This time, get a sheet of paper and let's sum up what you have learned. Choose the correct term from the enclosed choices that should go into the blank spaces. You may write your answers in your notebook. You do this in 60 seconds. Now, check your work using these key answers. Were you able to answer it correctly? Well, I still have here another activity for you to do. I want you to get another sheet of paper and I want you to copy the table that I will be showing to you. List down your exposure to the different forms of electromagnetic waves. Write the time duration of exposure and your activity. Then, identify the forms of EM wave involved and the source of the wave. For example, at 9 to 10 a.m., you are watching your favorite TV show. You're using a radio wave. Using the source, television. So now, it's your turn. And for your assessment proper, read each questions carefully and choose the letter of the correct answer. You may do this in your science notebooks. Now, check your work using these key answers. For more activities, you may also perform the additional activities found in your modules on page 15 and 16. So, this is your teacher Zaini, leaving you a quote from Malcolm X. Education is the passport to the future. Tomorrow belongs to those who prepare for it today. I hope you have learned something from me today. Let us always be safe. Thank you for watching. God bless.